Assalamualaikum and hello to my beloved lecturer. Okay. Today in this presentation, I will be introduce diode and explaining their function in electrical circuits. A diode is a semiconductor device that allows electric current to flow in only one direction. This unidirectional property makes it very useful in controlling the flow of electricity in a circuit. At the back of me, you can see that Mrs. can see that the picture of diode. Okay, diode are widely used for several purposes, such as converting alternating current AC to direct current DC, protecting circuit from voltage spikes, and modifying electric signal. In a sense, diode actually like one-way valve for electricity, making them essential components in many electronic devices. Next, all about diode, I will present and explain the next video. Okay, next, let's talk about rectifier circuits, which are used to convert alternating current or AC into direct current or DC. There are two common types. First, the half-wave rectifier, and second, the full-wave rectifier. Okay. First, we go to the half-wave rectifier. In the circuit, Mrs. can see my background, which is the diagram of the half-wave rectifier. In this circuit, we use a single diode in series with a load resistor. When AC is applied, the diode conducts only during the positive half cycle of the input. During the negative half cycle, the diode becomes reverse biased and blocks the current. As a result, the output across the load is a series of positive half sine wave with gaps in between where the current is blocked. This creates a pulsating DC output. Okay, the second rectifier, which is the full wave rectifier. Okay, this is the second picture, full wave rectifier. Okay. A full wave rectifier use either a center tape transformer with two diodes or a bridge rectifier. During both the positive and negative half of the AC input, different pairs of diodes conduct in such a way that the current always flows in the same direction through the load resistor. This result is an input where both halves of the waveform are converted into positive pairs. The output is more continuous and smoother compared to half-wave rectifier. Okay. So, lastly, we compare the both of a diagram. At my back, on the top, the half-wave rectifier, and the bottom is full-wave rectifier. Okay, I will compare the both of the diagram. In a half-wave rectifier, we only get output for one half of the input signal, making the waveform less efficient with more ripple. In contrast, a full-wave rectifier provides output for both halves, leading to a higher average output voltage and a smoother waveform. This makes full-wave rectifiers more efficient and better for power supply circuits. Okay, next, I will show the before this I show the diagram, and now you can see at my back the waveform of the half wave and full wave rectifier. Okay, you can see that the half wave rectifier like this, and half wave full wave rectifier like this. Okay, next we go to number 3, clipper circuit explanation. Okay, let's take a look at clipper circuit. A clipper circuit is a type of electronic circuit that is designed to remove or clip certain portion of an input signal without distorting the rest of the waveform. Okay, so how does a clipper work? Okay, I will explain. A clipper uses a diode, often combined with resistor and sometimes a voltage source, to block part of the signal that go above or below a certain voltage level. When the input signal reaches that level, the diode becomes forward biased and conducts, shorting the signal to ground or another reference point. This prevents that part of the signal from appearing at the output. Okay, now let's start with a positive clipper. In this circuit, you can see that at my back, Mrs. can see that at my back. Sorry. Okay, in this circuit, a diode is connected in series or parallel in such a way that it clips the positive part of the input waveform. For example, when the input voltage exceeds 0.7 volt, the diode conducts and diverts the current, effectively removing that part of the signal. Okay, the output waveform shows only the negative portion of the input. Next, for the negative clipper, the diode is reversed. It becomes forward biased during the negative half of the input cycle and clips it, allowing only the positive portion to pass through. Okay, using circuit diagrams helps a lot here. Okay, Mrs. can see at my back, on that pictures, these simple circuits and showing the input and output waveform. Mrs. We can clearly see how the clip signal is shaped. This waveform will show sharp cuts where the diode start conduct. Clipper circuits are very useful in signal processing, waveform shaping and voltage protection. For example, they can limit voltage spikes that might damage sensitive components. Okay, next we go through to experiment half rectifier circuit. Okay, at the video you can see that the cable to the breadboard, this is the circuit full half wave rectifier. Okay, next probe to crocodile clip from oscilloscope, channel 1 and channel 2. Okay, that picture show the wave of half wave rectifier, and this picture show the setup of function generator. Okay, this is the full setup of half wave rectifier done. Okay, next full wave rectifier circuit. Okay, in this video we all can see the setup of oscilloscope. Okay, and then transformer, connector, crocodile clip to diode, it's connecting to diode, and then the cable of BNC to crocodile clip, and you can see the sine wave. Okay, Okay, now we go through to clipper circuit. Okay, in this video you can see that connector using BNC to crocodile clip from function gen. Okay, they connect at there and set up of function gen. Okay, now set up for oscilloscope using BNC to crocodile clip. Okay, that's the connect channel 2, channel 2. Okay, from DC power supply, negative to ground and positive to crocodile clip. Okay, done. Okay, this is the setup of function generator, and this is the circuit on the breadboard for clipper, and that's the setup for DC power supply. Okay, in conclusion for this video, it's to conclude this experiment, demonstrate the working principle of rectifier and clipper circuits using diodes. We observe how rectifier convert AC to signal to DC, with the half-wave rectifier allowing current during only 1/2 cycle, and the full-wave rectifier utilizing both half cycle for better efficiency. Similarly, the clipper circuit show how the diodes can be used to remove or clip portion of a signal above or below certain voltage levels, modifying the waveform as needed. These circuits are crucial in real-world electronic. Rectifiers are widely used in power supply for converting AC to DC, which is essential for most electronic devices. Clippers are used in signal processing to limit voltage levels, protecting sensitive components, or shaping signal for specific application. Understanding this circuit lays the foundation for more advanced electronic and their practical implementation. Okay, this is all about the diode and 3 circuit, half wave, full wave and clipper. Okay, done.